Okay.
Hello, I'm here with a student and we're just working through one of the ALEKS problems for chapter 7.4. And it says you're looking at a population and are interested in the proportion of that characteristic. Unknown to you, this population proportion is 0.65. You have taken a random sample of sample sizes of 105 from the population and found that the proportion of the sample that has characteristic is 0.63. Your sample and sample one in the table, and then they're going to want us to take more samples. So go ahead and scroll down, Adam.
Mhm.
And it says, I'm going to make this view just, there we go, it's bigger. So if you scroll up for just one moment, we're going to run the samples. So go ahead and hit generate samples for us. Okay, and then remember on the video I made earlier, I talked about the 75% and the 90%. So the 75% confidence interval tells us that 75% of the samples should contain the red line, which would be the population proportion, which I think they said was 0.68 above, if I remember correctly, or maybe it was 0.65. What was it at the very top? 0.65. There it is. And then the 90% should contain 90% of those 20 samples. So 18 of those samples should contain in the blue line there, that 0.65. So if we went down and we counted on the 75%, that means 25% of the 20 samples will not contain. So either about 4 or 5, depending on the situation. So there's 1, 2, I can see on the screen. Let's scroll up and see if there's more that do not contain. There's 3, 4 right together, and there's 5. So there are 5 in that 75% confidence interval column that do not contain the true population proportion, which is what we would suspect. And then over in the 90%, we would suspect 10% of them or 2 of them do not contain. And it looks like there's 1, 2, 3 samples, 2, 8, and 9 are the 3 that do not contain the true, or sorry, samples 4, 9, and 10 do not contain the true population proportion of 0.65. Okay, so let's scroll down and look at the questions that they're asking us. So where's A and B? Are those at the top?
So A is the where you're setting the limits.
Okay, so this is based on sample 1, graph 75% confidence and 90% confidence intervals for the population proportion. Use 1.1415 for the critical value for the 75% and use 1.645 for the critical value of the 90%. So we have to go, and this is for the population proportion, confidence intervals for the population. And so we click on that list of formulas. And we scroll down. So if we go up just a couple more, okay, right there. So it says, like the fourth one down, it says estimating, nope, not that one. Sorry, scroll up. Estimating standard error, go down. I'm trying to find. Okay, estimating P via the confidence interval. Okay, so our standard, our P hat is going to be there, and then we're going to be taking the square root of the P hat times 1 minus P hat over N. So there's a lot of P's going on in this equation. So can you unshare your screen for just a minute for me, Adam? And I will share my screen. And let's go to that. I'm gonna go to the notes here. And this is 7. And we're gonna just scroll down here for a minute for proportions. So we're gonna scroll all the way to 7.4. And so we have to calculate for this hypothesis test, we have to calculate p hat, which they gave us for the sample. And then the z, they told us what they want us to use for the two z values and the critical value. And then the square root of the p hat times 1 minus p hat over n. Okay, so on your screen there, sorry, can you go back to your, I'm gonna let you share your screen again. So we can get, they want us to do sample 1. So if we go, you can exit out of the formulas and we'll go back to sample 1. So we're going to do one that's the critical value is 1.15 and the other one, the critical value is 1.645. So that kind of takes away that ambiguity of those questions, which is nice. And then the sample mean for sample 1 is 0.63. And then we're just going to use that in our square root. So it's going to be 0.63 times 1 minus 0.63 divided by n. And n is, they said there was a sample of 105. So I'm going to share, oh, if you don't mind, I'll share my screen again, just so I can share my paper for students to see. Okay, there we go. So this is the formula we're using. And this is going to be a plus or minus here. And then this will be the 90% down here, plus or minus. And then we'll fill these. So it's your p hat. This was from sample 1's p hat. And then we're using the p hat in here. And then n was 105. So we're going to pause the recording for a minute. I will do that so that everybody can work for a moment and we'll figure out what these are and we will come back. Okay, so here is some of the calculation on the calculator for what we've done. And we're going to, hopefully everybody at home has started doing theirs, but we're going to go ahead and have Adam enter the confidence intervals that we came up with, boundaries for the 75% and 90%. So we have, we all agreed on 2 decimal places here at 0.57 and 0.68, and then 0.55 and 0.71. And just a reminder at home that the higher the confidence, the wider the interval. So that would make sense that the 90% is slightly bigger interval width than the 75. Okay, so let's scroll on down to where it gets fun with all the questions, part C and D. So we generated 20 samples, and now they're gonna ask us a question. So it says, notice that for 18 out of 20, the samples, the 90% confidence interval contains the population proportion. Choose the correct statement. So is that what we found? There were 18 of them. There were only 2 that did not fit in the 90%.
Yep.
1, 2. Okay, yep, just want to verify that. Okay. So let's go back to our questions here. So it says choose the correct statement. So that's telling us that there's only one correct. So when constructing 90% confidence intervals for 20 samples of the same size, exactly 90% of the samples will contain the population proportion. We know that's not true because that would be 10% of 20 would be 2. In this case, it did, but in the 75%, it did not. So that's not true. Let's look at the second one. When constructing 90% confidence intervals for 20 samples of the same size, at most 90% of the samples will contain the population proportion. That's not true because it could be more or less. And the third one says, when constructing 90% confidence intervals for 20 samples of the same size, it is possible that more or fewer than 90% of the samples will contain the population proportion. That's the true one. Okay, let's look at D. It says, choose all that are true. Okay, great. The 75% confidence interval for sample 6 is narrower than the 90% confidence interval for sample 6. Okay, they should be, right? This must be the case when constructing a confidence interval for a sample. The greater the level of confidence, the wider the interval. I just mentioned that, so that one's true. Okay. To guarantee that a confidence interval will contain the population proportion, the level of the confidence must match the sample proportion. For example, if p hat equals 0.47, then the 47% confidence interval will contain the population proportion. No, that's just weird, and those have nothing to do with each other. Okay. Third choice, from the 75% confidence interval for sample 6, we know that there is a 75% probability that the population proportion is between 0.49 and 0.82. Let's just go up and make sure that those are the lower and upper boundaries, but I'm confident that that is true. And what was, they were asking about sample 6. I can't see the whole thing. Can you see?
Yeah, was it the 75 or the 90?
Let's go back down and look. I can't see your whole screen. You might be able to see it. So it said 75% is what we were looking at, and they said 0.49 and 0.82. So let's go and look, because I don't think that's true. It was sample 6, right? And that is not true, because their lower boundary is only 0.59 and the upper is 0.69. So that's not true. Okay, let's look at the fourth one. If there were a sample 21 of size 160, so we're increasing the sample size, with the same sample proportion as sample 6, then the 90% confidence interval for sample 21 would be narrower than the confidence interval for sample 6. So this is a great question. So this has to go back to changing if all else stays the same, which is what they said, except for the sample size. We're going to go from 105 to 160, and we're thinking about what changes in our confidence interval formula when we increase our sample size. It's that denominator, right? And when our denominator gets bigger, our fraction gets smaller. And when the fraction gets smaller, the square root of that same fraction continues to get smaller. So that means you're adding and subtracting a smaller value to your sample proportion to get the interval. So that means it would, in fact, get more narrow. So I would agree with answer 4 as well. Cross your fingers and let's check it.
Hey.